Hello, and this is a session where we are going to tackle a Cdacc technical drawing paper for building technology level 5 applied technical drawing. So this is a paper that was done in March 2025. Cdacc, and we are going to tackle section A, which carries 40 marks. So we shall call this a marking scheme for TVET Cdacc paper, which we have already described as building technology level 5, applied technical drawing, that was done in March 2025. So the instructions are as follows. One, this paper consists of two sections, A and B. Most students don't even read these instructions. Question 2, attempt all questions in section A and any three questions in section B. Marks for each questions are indicated in brackets. Then candidates are provided with a separate answer booklet. Don't write anything on this question paper. So, as we have said, this is a Cdacc TD March series 2025 question, which we are going to tackle. And we are starting with section A, which has normally 10 questions, but this one has 11 questions, totaling to 40 marks. So let us start. So the first question, attempt all questions in this section. First question here reads as follows: orthographic projections. Create an image where only two of the three dimensions of the object are seen. Up to here, we have not started getting the question. This is just a description. Then the question starts from draw the conventional symbols used to present each. So what is required? The symbol for first angle projection and the symbol that indicates third angle projection. So the symbol for the first angle projection, we shall notice that this one here is the front elevation, and this is the plan of a cone, a truncated cone. So that would mean that this is on top and this is below. Same to this arrangement in the third angle projection, that we have the plan on top of the front elevation. So the arrangement is not supposed to be lying horizontal. The arrangement should be upright, as shown here. The arrangement should be upright so that we have the plan on top of the front elevation for third angle projection and the front elevation on top of the plan for the first angle projection. So this is actually the answer to the question, and we should always take care so that this front elevation is not inverted. If this the elevation is inverted, I normally give an analogy of a skirt. the skirt should be worn in this format. So if you find the skirt upside down, that means that uh, the whole drawing is upside down, and therefore you have to cut the whole drawing, make the skirt upright. And as you do that, you will either find your plan coming down or your plan going up. So a second question is, it reads, various lines in technical drawing are used as alphabets of the graphic language. Draw and name any 3 different lines used in the technical drawing. You can see that presented here is almost 11 different lines, although we just mentioned these lines, break lines, center line, construction lines, curved lines, cutting planes, dashed lines, dimension line, extension lines, hidden lines, isometric. Let us see how these lines really look like, so that as you also provide the name, you need to also draw that line. So here we have a construction line, and the construction line as compared to the finished line is only the thickness, only the intensity of darkness. This line is thin and dark. This line, this line is thin and light. This one is thin and dark. That's the difference between a finished line and a construction line. Then we have a leader line for pointing to hidden details or details of an object, so that we are able to name various parts of an object. The cutting line, this one is used for cross-section, cutting through a building, cutting through an object, so that we are able to see the inside part of that object. Then the dashed lines for hidden details, yeah, where you cannot see edges and corners that are not visible from the front, that are hidden by the front part, can be drawn in dashed line in order for us to be able to see what is what how the edges are placed at the back. Then we have the chain line for indicating centers of circles, centers of pipes, and so on and so forth. Then we have the dimension line. This is dimension line for just indicating the dimension of objects, for sizing objects. Then the broken line is also called continuity line. This line helps us in uh, breaking drawings that would otherwise not fit in a drawing paper. So we cut that drawing and show that the drawing is still continuing even as we cut it because of the space. So those are some of the drawings, a few of them, and plus the whatever. We are only required to do 3, and we have done more than 3. Then we go to the next, which is angles in technical drawing. Give trainees knowledge on how to draw inclined lines of architectural drawing. Construct the following angles, and we've been given angle of 105 and angle of 75. This question may be a bit tricky, but as I see, there's no restriction on how to draw the angles, and therefore we can use the protractor, we can use the pair of compass, we can use any method that comes to our mind. And because we are not restricted, the easiest method is just to draw a horizontal line, and then using your protractor to measure, and you will be able to draw 105 degrees. Same to this one. But if there was a constriction on what method to use, especially when you are told to use a pair of compass alone, then this becomes a little tricky, and that means that you have to find, because these seem to be combined angles. They seem to be combined angles because in the angles we have two parents, which is 60 and 90. Then from 60 you get 30, you get 15, and you go down as you go down like that. And from 90 you get 45, you get 25 and a half, and so on and so on as you go down. Then those angles can be added together. Like here, we can see that this is an angle of 90, a combined angle of 90, 90 plus 15, giving us 105. And this one is 60 plus 15. So you draw an angle of 60 using a pair of compass, and then on top of that 60, you add an angle of 15. And in the first case here, you draw an angle of 90 degrees using your pair of compass, and then you add an angle of 15. That is if the equation here constrains you to draw the angle draw the angle using a pair of compass, of which this question does not direct you which method to use, and therefore you can just use the simplest method, which is just to draw a plane, a baseline, and then use your protractor to get the angle. Question number 4, various tools are commonly used in a workshop. Make a freehand sketch of a ball peen hammer, and the ball peen hammer is given. Here what you need to do is make sure you have proportionality. If the head of the hammer is small, then the handle should be proportional to the head. Let's not have a situation where you are drawing a big head and a very tiny handle, or a big handle and a very tiny head. So proportionality is what is will give you a good drawing. And you need to know all the tools that are used in the in the workshop, so that should you meet such a question, you already know how it looks like and you can sketch it. Question number 5, the following are commonly used drawing equipment. Outline 2 ways can safety and care be given for each. I think there's something amiss here. That construction of word is not very construction of this sentence is not very very correct. Outline 2 ways can safety and care be given for each. I think we get the meaning, even though there is some um, word misplacement. So A is t and set squares. How do you take care of t squares and set squares? You can keep them clean by washing them with a soft piece of cloth and soap. Avoid placing them where they can be prone to dropping. Yeah, if you drop your instruments, they are liable to break. Sharpening the tip frequently to avoid dulling. This is a pair of compass that has a pencil tip, so as to keep your drawings sharp. You need to continue sharpening your pencil and taking care of the tip. Then placing them on a clean surface. Place your instruments so that they don't collect dust. If you place them in a dirty place, they'll be collecting dust, and that dust may find its way in your drawing. And as we know, that neatness is very paramount in making your drawings look good. These are only a few ways of doing that. You can get some more. Now the next one is question number 6. Divide a line segment into equal parts. Dividing a line segment into equal parts is a fundamental geometric construction that demonstrates precision. Draw line AB of 70 and divide it into 5 equal parts. So here you simply draw a construction line, that the line AB. You draw that line, measure 70 millimeters. Then after you have drawn that, you can see the procedure here. You draw this assisting line. This line is called an assisting line. You don't measure the angle, but let it be less than 45 degrees. Let's not have an angle that is wider than 45, although it can work, but it will be clumsy. So draw that assisting line, and after you've drawn this assisting line, just stretch your pair of compass like you can see this distance here. Don't stretch it too much because that would make the line AC be very long. So just have your a reasonable stretch like we can see on the diagram, and strike 1, 2, 3, 4, and 5 because we are dividing the line into 5 equal parts. So on the fifth part, the fifth point here, you can connect C to B. You connect C to B. You can see that is done in red so that we maintain the parallelism between this line and these other lines. It should be parallel. We can use our pair of compass to now this line and continue drawing these other lines from those various points. And that is actually that will give us the division of that line AB into 5 equal parts. Now, question number 7, any geometric shape can be circumscribed or inscribed. In a circle, I think there's a point that is missing there. Draw a triangle of sides 55 millimeters, 72 millimeters, and 80 millimeters, and circumscribe it with a circle. So you can start with any of these. You can start with a 55 millimeters line as a baseline like that. You can start with 72 as the baseline, or you can start with 80. So here we can see that 80 has been placed at the baseline. Then your pair of compass is stretched 72 millimeters, as you can see here. Stand at this point and you'll be able to strike this you'll be able to strike this arc. Then stretch your pair of compass 55 millimeters as shown here. Place it at the end here and you'll be able to strike this other one. And then now from this point you can be able to draw a line to this end, draw another line to this end to end up with this triangle. Once we have this triangle, because we want to circumscribe, for circumscription, we need to bisect any two sides of the triangle. So bisect this side, you get this line. Bisect this side, you get this line. And where there's an intersection here, place your pair of compass, stretch it to this end, and you'll be able to draw that circle circumscribing the triangle. Question number 8. Three-dimensional diagrams have a length, width, and height. List 4 types of 3D diagrams in technical drawing. The first one will be isometric, and the isometric angle is 30 and 30. 30 by 30. Then the second one is oblique, and in oblique we have 90 degrees by 45 degrees. 90 degrees or 45. Some people like to call it 0 degrees by 45. So one side of oblique is lifted at 45 and the other one stays placed on the baseline. Then we have the axonometric projection, which has an angle of 60 by 60. And the perspective drawing, we shall have the 3-point perspective, the 2-point perspective, and the single point perspective. So here we can see isometric at an angle to the base here 30-30. We can see axonometry an angle here 60 by 60, and then we can see the oblique at 90 by 45. Yes. So how about the perspective? The perspective, we can see that this is a 1-point perspective with one vanishing point here. Then this is a 2-point perspective with 2 vanishing points. Then we have the 3-point perspective with the 3 vanishing points, one here, next one here, and another one down there. All right. So let's move to number 9. Question number 9 reads, in technical drawing, different drawings are produced for various purposes. Outline the purposes of the following drawings. And we've been given a sectional drawing and an assembly drawing. So what is a sectional drawing for? Sectional drawing reveals hidden interior details. It shows what's inside by slicing through the object. The object is sliced, one part is removed, and then the remaining side now will expose the inside or the parts that are hidden. Essential for understanding structural composition, for showing how the various parts and components of the object fit together. This is very common in cross-section for foundation, cross-section for building, to show us how deep the foundation is and what the foundation is composed of, because the foundation is normally hidden inside the ground, and therefore the cross-sectional drawing would be the best to expose what is inside the ground. And then we have the other one for assembly. This shows components, how they fit together. It displays the arrangement of parts to form a complete unit of structure, essential for understanding overall functions. You'll find, go to the supermarket and you buy a component that has been dismantled. You need to have an assembly drawing that shows you how this part fits with this part, how these parts come together to make the whole. So cross-sectional drawing, as we can see there, it shows us this cross-section through a building, showing us the foundation, showing the thickness of the wall. It shows us the roofing materials, what has been used. On this other side, we can see an engineering drawing where this object has been sliced. One side has been removed so that we are able to see the thickness of the inside, and we can be able to draw that one here. So this one shows an elevation. That's why we have dotted, meaning that we have not cut it. But this one now exposes the inside, meaning that the cutting is what we are drawing. So assembly drawing, we can see this a self-explanatory drawing of a lock, a door lock. It shows us how each and every component fits together. So if you are given these components, parts, you can be able to bring them together because of this drawing. Uh, uh, this is a question that was not asked, but maybe it could help you. Working drawings. Working drawings are detailed technical documents used in construction, engineering, and manufacturing to guide the actual building or production of a structure component or system. They translate design concepts into precise, actionable instructions. So, working drawings, we can see an example of working drawings. These are the key features of the working drawings, and some of the common working drawings are architectural drawings, floor plans, elevations, sections showing the layout and design, and so on and so forth. So this is an example of a working drawing. It shows us the thickness of the wall. It shows us the dimensions, how wide is the sitting room, the dining, and so on and so forth. Where do we place the door? Where is the kitchen? Where is the so this is what actually is referred to as the working drawing. Then we also have a detailed drawing. Detailed drawings is actually a drawing that seeks to name parts of the drawing, to give us the actual materials that are used. This is a cross-sectional drawing, and at the same time it is a detailed drawing. Cross-sectional, why? Because it cuts through a wall and a foundation of a building. But the purpose for this particular drawing, as you can see, is to show us the details of all the materials that have been used and how they have been placed. In question number 10, building drawings can be printed in different paper sizes depending with the client's interest. Um, give the dimensions of the following drawing paper sizes. So the question here is asking you for A4, A0, and A3. But for us to be able to memorize these, let us have all the papers available, the range of papers that are available. That is from A4 to A0. And all you need to do is just to memorize A4 paper, which has the dimensions of 210 by 297. So once you have A4, which has 210 by 297, you always remember that moving to the next paper size, we will double the shorter side and just move the longer side to the next paper size, so that 297 has just been moved down to A3. It is the longer side. And then the shorter side has been multiplied by 2. You can see 420 by 297. We go to A2 paper size, which is the longer one up here. The longer one is 420. So just bring 420 down and then multiply the shorter side by 2, and that will give you 594. So that's A2. Going to A1, so going to A1, check for the longer side here, which is 594. Bring it down to A1 and then multiply the shorter side by 2, you get 820. Same to the last one here, A0. A0, which we shall just identify the longer one, 820, bring it down and then multiply the shorter side by 2, and we have our A0. That's a simple method of remembering these paper sizes, and we can generate paper sizes from A4 up to A0. Question number 11, I think this must be the last question. Architectural drawings can be drawn by use of manual method or by use of computer software. List 3 advantages of using CAD other than manual drawing. CAD stands for Computer Aided Design, and therefore we are talking of AutoCAD, we are talking of ArchiCAD, and some other CAD systems. So what is the advantage of using the computer aided design to the manual process? One of them is accuracy. Computer is normally very accurate. Standardization, that if I'm using a certain software, I'm using a certain CAD software, the result that I get will be the same that you get if you input the same figures. Speed, it actually can reduce the amount of time that is used, especially like when you're using ArchiCAD. ArchiCAD, as you draw the plan, you are also developing the height and the walls. And in ArchiCAD, we just use materials. So to place the roof is just simple. Just draw uh, the roof position, and it will give you the roof automatically. Draw a line for the wall, and it will give you the wall. Then just place the windows where you want them after you have so it's quite easy and speedy. Possibility of handling complex drawing. You can handle very complex drawing because you are able to pan, you are able to reduce, you are able to pinch and expand the diagram, and to see all the details of the very minute parts of that drawing, which is not possible with this other. You can draw different in different scales, on the same drawing, as you pan, as you magnify, and as you then the virtual drawing storage. You can be able to store very many drawings in a small flash disk. Ease of sharing far and wide. You can easily turn it into a PDF and send it anywhere in the world. Versatility in integration with other softwares. You can be able to use ArchiCAD, and a drawing that has been done in AutoCAD can easily be integrated to ArchiCAD and continue making it even better. And it's not only ArchiCAD, there are many CAD systems that will borrow from each other. So this marks the end of section A. I hope we shall meet in section B. My name is David N. Kamau. Thank you for your cooperation.